Hello, Algebra 2. We are taking a look at lesson 6.3, some more stats related stuff. Right about now, right? Your first name, last name, that info is starting to pop up for you to answer. Um, let's go ahead and start off the notes, right? Keep this short and sweet. So, the first thing we're looking at is just some definitions. So there are organizational tools. One of them we call measures of center. And the way we measure center is using mean, median, and mode. So those are measures of center. Then there are measures of spread, meaning, well, of course, how spread out the data is. And we use range, IQR, and standard deviation to describe those things. And there is measures of shape, which I'm sure you can take a guess is like, what's the shape of the data? We measure that through stuff like skewed to the left or to the right. Oops, not a comma in between. We describe it as either skewed left or skewed right, or we might call it symmetric. So let's talk about these things and how they're all related to each other. So this graph right here, you can see the measures of center, right? Mean, median, and mode. And we're not really describing spread here, but we're also describing the shape. And in this case, the shape is left skewed. Why is this left skewed? Because there is a tail on the left, okay? We call this left skewed because there is a tail on the left. The hump is on the right, which I realize, but when we say skewed, we're talking about where the tail is. So that's left skewed. And so visually, that's why something is left skewed. But what about like mathematically in the numbers? Well, in a left skewed distribution, the mean, generally speaking, is always going to be less than the median. Okay, and that's going to be important. This right here, it says normal, or you might call it symmetric. Okay, this is a symmetric distribution, and the reason why it's symmetrical is because, the hump is right smack dab in the middle. There's a normal tail on both left and right, and number-wise, the mean is equal to the median. That, generally speaking, makes something symmetrical. And the tail is, of course, on the right for the right skewed graph. And this time, mean is greater than the median. This info will become useful in a smidge. Okay, these three things we'll want to know. Still talking about how to visually represent a graph. What are these things? What are these things below? These are box and whisker plots, right? These are box and whisker plots, and let's talk about them. Well, a box and whisker plot, generically speaking, looks like this. Right? It always looks something like that. So on the left side is always the minimum, and on the right end is always the maximum, and then the middle line is always the median. I almost said mean, but it's the median, and then on the left here is Q1, and on the right here is Q3. And Q1, a way to describe Q1, and I think we might have described it last class with the definitions. I don't really remember, but we'll say it again. Q1 is the median of the left half, and Q3 is the median of the right half. And if for some reason you don't remember what median means, median is the number in the middle. It's just a fancy word for the middle number. Okay. All right, so let's actually talk about these numbers, right? Instead of just speaking about definitions. Okay. Let's change colors. Here is the exam scores, right? There are however many scores there. I haven't counted them yet. Always make sure your data is in order, right? You don't want random numbers scattered around, right? All of these numbers only make sense if you've organized your data from smallest to biggest, okay? So that is already pre-done for us, of course. That would take way too long. But just in general, so that you know, right? That's an important thing to catch. So let's talk about those 5 numbers. So obviously the min is 57, and I'm pretty sure, obviously, to all of us, the max is 99. Let's talk the median. What number is in the middle? Well, now I kind of need to know how many numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the middle of 15 is 7.5. But basically, there are 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 numbers on the left, 7 numbers on the right, and then the 15th one right there in the middle. Do you see what I just did there? Right? 78 is smack dab in the middle. Why? Because there are 7 numbers to the left and 7 numbers to the right, making 78 the middle number. Okay? So our median is 78. So Q1 and Q3 is the middle of the left half, the median of the left half. So I'll do Q1 and the question will be Q3. So Q1 is the middle of the left half. So if I'm looking at the left half, that's only these numbers. Okay. How many do we have there? 1, 2, 3, 4, 5, 6, 7. So 3 on the left, 3 on the right, 62 is in the middle. So that's our left median, so to speak, our Q1. So how about you, real quick, tell me what Q3 is. So Q3 is, question pops up on screen. We have 1, 2, 3, 4, 5, 6, 7 numbers on the right. So 3 on the left, 3 on the right here. 84 is smack dab in the center. So that's Q3. 84. So there's our 5 numbers, and we can turn that into a box and whisker plot, where this is the min, this is the max, this is the median, this is the Q1, and this is the Q3. There's a visual representation, not drawn to scale, of course. I just roughly sketched it. So IQR, that was a measure of spread, right? Range and IQR are sort of similar. Range is the easy one. So let's talk range first. That's always going to be max minus min, which is 99 minus 57, which is 42. The range meaning how far apart is the biggest value and the smallest value. How spread out are these numbers? IQR stands for interquartile range, which means how far apart are the quartiles, Q1 and Q3. So let's make this question number 2. How far apart are the quartiles? What are those 2 numbers? And do the math. Question pops up. Q3 is 84. Q1 is 62. 84 minus 62 is 22. So the interquartile range is 22. I mean, pretty easy, right? If I said anything too quick, honestly, rewatch it. We literally just covered that problem in like 3 minutes. Um, I think those are all pretty straightforward, though. Okay, so let's take a look at this data. Using the data set below, create a frequency table and a histogram. Then describe the shape of the distribution. The run totals for 14 American League teams and 16 national teams for 2008. So there are 30 numbers there. So there are 30 teams, okay? So our total better add up to 30 in the end, or we miscounted. In this situation, we don't really need the numbers to be in order because the question isn't asking us for mean or median or anything like that, right? You only need the numbers in order if you're doing a 5-number summary, right? Because you need to clearly see the min, the max, and the middle number. This question isn't asking for any of that, okay? So the order of the numbers isn't as relevant here, okay? We only have to order the numbers from smallest to big if we're doing a 5-number summary. So let's just tally up what we see here, and I'll cross them out. You honestly might put me at 2 times speed while I do this, right? Because it's really not that hard to count. So 600 to 649. So where are my numbers? Here's 641. So there's 1, 2, 3, 4. Okay, so there were 1, 2, 3, 4 numbers that are from 600 to 649. 650 to 699. 650 to 699. 1, 2. Okay, I have 700 to 749. Just to make sure you're listening and know how to count, do that one for me. How many numbers are there from 700 to 749? Give you a second to count and question. So how many are there? 700 to 749. 1, 2, 3, 4, 5, 6, 7. 7. Okay. 750 to 799. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Switch color again. 800 to 849. If you don't have me on 2 times speed, you really should. 1, 2, 3, 4, 5. This looks like 5. 850 to 899. We're so close. 1. Just 1. And then the last one. Is there a number I haven't crossed out? Right there. And one of those. Okay, we did it. So you might slow me down now, so that way you know how to draw a histogram. So what's the first number? I made it purple. So from 600 to 649. 1, 2, 3, 4. Right? So that's that area, right? And then red here for 650 to 699. So less. And then that dark blue there. Oops, is that the right dark blue? Yeah. 700 to 749 is 7. That's what you guys counted. Oops, it's kind of ugly. So there's that one. And then orange, 750 to 799, so all the way up to 10. And then, what is that? A dark purple. So 8 to 849 is 5. And then green. And then pink. Okay, so there's that. So Is there a shape that you might use to describe this? You might say it's symmetrical, maybe, right? Um, but at the same time, I mean, it looks pretty symmetrical, but yet this higher up thing isn't nearly the same as the right side. So you might be tempted to say right skew, maybe? Because there's a tail here, maybe? Right? It's up to interpretation, right? This isn't, data points are not going to be perfect, right? That the world is not perfect, okay? So it is up to interpretation at some points. Okay. So we made our beautiful graph there. And the reason why I did that is because it said for us to describe the shape. I didn't just do that randomly, right? All right, last two here. We're only at 16 minutes. This is awesome. So analyze the different organizational tools. Be sure to reference the distribution, mean, median, and any other significant data. So analyze the different tools. So basically, which one should we use? Right? Which tool should we use? Right? Well, let's start to analyze this. This is most definitely right skew. Okay, because this is a tail on the right. If you go back up and look at our pictures, you can see how the box is on the left, right? The box is on the left versus the box being on the right. Okay. So that is most definitely right skewed, and a little less so, but I would say this is left skew, right? Not as dramatic as the first one, but definitely not symmetric. So we'll call it left skew. Okay, so what does that tell us? Well, recall, this is sort of some upper level thinking here, so bear with me here as we describe this. How many, if 70 is kind of your goal, right? 70 is a C, 70 is passing, right? Nearly 75%, this is at like 70, 2.5 or something, right? Nearly 75% gave it now how do I know that's 75%? But hold on a second. How do I know that's 75%? Well, Q1 is at 25%. And the median is always 50%. And then Q3 is always 75%, right? Because we broke it up into fourths. When you think of min, Q1, median, Q3, and the max, 25% of the data is here, another 25% is there, another 25% is there, and another 25% is there. So from min to Q3 is 75%. You with me? You with me on that? So like 75% of people gave it a low C or worse, right? And only 25% gave it a C or better. Now, looking at the other one, this is a mid-range to high D. But even if you don't look at that, right, half the people gave it a high C or better. And then we don't know exactly what percentage is right here, but I'd be willing to guess, somewhere around like 15-ish%, right? Because hopefully you see what I'm getting at, right? If I'm breaking up this data, here's 25%, here's 50%, here's 75%. Well, somewhere between 50 and 75 is right there, right? So maybe like 65%. So I open the floor to you. Here's my question prompt. Which movie ending would you use? The first ending or the second ending, and why? So, I wrote in highlighter the word question, so that way I knew where I asked the question. I would use the second ending. Because over 50% gave it a C or better. First ending, nearly 75% gave it a score worse than a C. I know I wrote that super sloppy, but you heard me say it. Okay, and then this last one, real quick and real easy. What shape is this? Symmetric. And if we were to analyze this, right, if it's symmetrical, we would just say, I mean, I don't know. What is there to say about this? You could practically end the video here if you wanted to. I'm just going to make something up, right? I mean, the majority of people, I'm not going to write this down. The majority of people, or the majority, you know, they're mostly making 8 to 11 cappuccinos per hour, right? I don't know. There's not much to say here, right? This was a cool comparison. This is not as exciting. So we'll call it there. All right. Thanks for answering those 3, 4 questions, whatever it ended up being. I forget. I'm about to record another one. I'll see you later.